Animate and Inanimate by William James Sidis. Chapter 6. Solution of the paradox. We have seen that the second law of thermodynamics, if pushed to its logical conclusion, leads to absurdities, that, on the basis of the other physical laws, it is most extremely improbable, and that it cannot have been universal for all time past unless we assume some sort of creation or some other form of miracle. On the contrary, we have seen that the probabilities from the physical laws governing the motion of particles, which are all reversible, and whose consequences must therefore be also reversible, lead us to the conclusion that, though the universe as a whole will tend to be neutral in that respect, yet, in certain limited portions of space and time, the second law of thermodynamics represents a prevailing tendency. We may easily, therefore, suppose that the portion of space and time under our observation, which, as we know, is very limited, is just such a section, and that the second law of thermodynamics represents a prevailing tendency of energy to level down in our vicinity and in our epoch. This would seem to be the only way leading out of the paradox which seems to follow from the second law of thermodynamics, so that as this law is thus supposed to be true only for a limited epoch, there is no necessity to suppose any creation or other miracles, and therefore the rule for the whole universe is really reversible. This would apparently solve our paradox, if not for the fact that, according to this proposed solution, the second law of thermodynamics would represent, not a constant law, as observations would indicate, but, on the contrary, merely a prevailing tendency, with a number of instances of reversals of that law in our own part of space and time. Thus we find a difficulty in accepting the solution of the paradox, namely, that our proposed solution requires that, even in our own section of space and time, there must be many instances of the reversal of the second law of thermodynamics, which seems contrary to observed facts. And yet, considering that the second law of thermodynamics itself leads to absurdities, it might be worthwhile to inquire whether, after all, there might not be in our portion of space and time certain instances of the reversal of the second law, certain events with what we have called a negative tendency, which might have escaped our attention. In order to conduct this inquiry, we would have to find some way to recognize such a reversal, should any be found. This can be done in two ways, either by translating common occurrences into the reverse universe, and thus familiarizing ourselves with how such a reversal looks. A moving picture outfit could easily bring this reverse universe before the sense of sight, by operating the reel backwards, or else we can reason from the abstract second law itself and infer from its reversal certain easily recognizable outstanding characteristics. We shall proceed in both ways, starting with the abstract method, then using the other method to fill in, as it were, by way of illustration. One characteristic of the second law of thermodynamics is that there is, under it, a tendency that large causes should produce smaller effects, some energy becoming lost always in spreading heat throughout the universe, while small causes rarely, though occasionally, produce large effects. Now, since it is always possible to regard any event either as caused by past conditions, reasoning from cause to effect, or as being the cause which will produce the conditions of the future, reasoning from effect to cause, both cause and effect of a given event being a determined thing, we may say that, under the second law of thermodynamics, since a given event is likely to have more visible causes and less visible effects than itself, it follows that, under the second law of thermodynamics, it is easier to explain an event as the effect of past causes than as the cause of future effects. In other words, under the second law of thermodynamics, though reasoning from effect to cause is possible, it is almost necessary to reason from cause to effect, as the physical sciences usually do. On the contrary, when we have the negative tendency, when the second law of thermodynamics is reversed, the reverse is the case. Under the negative tendency, energy is constantly being reclaimed from the enormous heat reserve which otherwise lies unused, and this will be happening at every occurrence taking place under the reversed second law. Thus the tendency in such a case will be that, while occasionally large causes will produce smaller effects, yet as a general rule smaller causes will produce larger effects. In other words, a given event is most likely to have less visible causes and more visible effects than itself, so that, if we try to explain an event as the effect of past conditions, we shall always have difficulty, because part of the cause in any case, and sometimes even the entire cause, will consist merely of diffused and undifferentiated energy which cannot be observed unless we can keep track of every individual particle of matter. But, on the contrary, if we try to explain such an event as being the cause determined by future conditions which are its effects, such an explanation is simple, because the full effect is observable, and the effect is usually more visible than the cause. The result is that we get one distinguishing characteristic of that reversal of the second law of thermodynamics for which we are looking. If we find such a reversal, we will, in all probability, be finding some sort of events which it is easier to explain from the future than from the past. In other words, we must, in looking for such a reversal, look for something which, while it acts under the ordinary form of causation like the common physical bodies, yet appears teleological in nature. This teleology is only apparent, for causation under the negative tendency is no different from ordinary physical causation. In causation in general, the reverse or pseudo-teleological explanation is always possible, but is more obvious in the case of a reversal than in the ordinary case of positive tendency. Thus, when we wish to find a reversal of the second law of thermodynamics in our section of space and time, we must look for phenomena with an appearance of teleology. Another outstanding characteristic of a reversal of the second law is the ability to use the immense store of energy which, under the second law of thermodynamics, is unavailable. In other words, a reversal, besides the property of apparent teleology, must also possess the property of ability to use a store of reserve energy, some of which is always used, while at times even all of it could theoretically be used and converted into visible forms. So we thus get theoretically two outstanding characteristics of the reversal for which we are looking, namely, apparent teleology and the ability to use a fund of reserve energy. If we can find anything in our section of space and time which has these two properties, then in all probability we have found the reversal for which we are looking. Now, to take the more concrete method, that of observing the reverse universe, either by reversing any common occurrence, or else in observation by reversing a motion picture film, etc. We have already seen that a reversal of such an incident as a ball rolling down a flight of stairs becomes, in the reverse universe, the following: the floor and the stairs successively throw the ball upstairs, the ball itself aids the process by giving a jump, as it were, each time it lands. This would give floor, stairs, and ball somewhat an appearance of being alive. In fact, in any case, all ordinary physical objects will act in the reverse universe somewhat as if alive. Instead of rivers running down to sea, we would have in the reverse universe the situation of sea water rejecting its salt and then jumping up the river channel to the source, where the water, separating itself first into drops and then finally into molecules, makes a final jump up to the clouds. In other words, the water is constantly jumping upwards, as though of its own volition, and aided at each step by the ground pushing it upwards or even throwing it up. Here again there is an appearance of life in objects that we would certainly, in our universe, consider as dead. Take a more complicated instance, the behavior of drops of mercury on a smooth surface, consisting, we may suppose, partly of metal. These drops, in our universe, would roll around under the influence of any external forces that may happen to be present, unite if two happen to come together, and, in case they touch metal, the drop will shrink and partly amalgamate with the metal. In the reverse universe, on the contrary, we have a different arrangement. The drops will roll around as before, but, in their rolling, will avoid the pure metal surfaces, but will tend to roll over the amalgam surfaces. When in contact with the amalgam, they will extract the mercury, and thus the drops will keep growing. When the drop grows in this manner to a large size, there will appear a constriction, and finally a division into two drops, each like the original. This action of ordinary mercury drops in the reverse universe corresponds in many details to the growth and division of living cells in our universe. In short, We may say that, in general, events in the reverse universe appear as though they were living phenomena, and the general events of the reverse universe may be taken as the type of negative phenomena, of the reversal of the second law of thermodynamics. We should thus expect, in the real universe, to find such reversals in some sort of living or apparently living phenomena. Furthermore, if we find in the reverse universe some phenomena that, contrary to what might be expected, obey the second law of thermodynamics, it must follow that the corresponding phenomena in the real universe must be precisely those reversals for which we are looking. Inasmuch as we have seen that ordinary inanimate phenomena take on an appearance of life in the reverse universe, let us see what becomes of living phenomena in the reverse universe. Let us inject some sort of living agency into any previous illustration of the reverse universe. Suppose, in the case of the ball rolling downstairs, that it was originally thrown by someone. The beginning of the incident, which will correspond to the end in the reverse universe, will consist of a human arm starting to move, carrying the ball forward against the resistance of the air, finally letting the ball go, after which the ball, on the momentum thus acquired, proceeds to bounce down the stairs. In the reverse universe, the ball, properly aided by the floor and the stairs, comes jumping upstairs into the hand. The ball, though it tends to be speeded up by the air pushing the ball along, and by the heat energy of the ball similarly reacting on the air, yet slows down quickly and finally comes to a stop. The acquired momentum of the ball moves the hand, swings the arm, and finally the molar energy thus transferred to the arm becomes transformed into heat, and the arm stops. This very last part of the incident is a rather unexpected case of the second law of thermodynamics in the reverse universe, and we may note, as a result, that the living body, when reversed, becomes a mere obstacle instead of a moving force. We may therefore conclude, first, that inanimate phenomena, when reversed, become animate; second, that animate phenomena, when reversed, lose the appearance of animation; and third, that animate phenomena, when reversed, lose this appearance because, when reversed, they tend to follow the second law of thermodynamics. The logical conclusion from these would be, that inanimate phenomena are positive tendencies, and follow the second law of thermodynamics, while animate phenomena, on the contrary, are negative tendencies and tend to reverse that law. Thus we have found where our part of the universe contains reversals, and come to a solution of our paradox.